All right, welcome to section 8.4, special right triangles. Following in the footsteps of what I called the most important lesson, Pythagorean theorem, this is shortly below it. This special right triangles has such an important part of what you're going to be doing on the SAT, the ACT, pre-calculus, and on and on. So this is a really, really important lesson. There are three hugely important sets of things in this chapter. It's the most important chapter, too. Hopefully the glare, it's a nice spring day, I'm outside, hopefully the glare is not bothering you, but let's get right to it. All right, there are two special types of right triangles. The first one is an isosceles right triangle, okay? So if it's an isosceles right triangle, these sides are going to be congruent, the angles are going to be congruent, so they're both equal to 45, right? If you got a 90-degree angle, right angle, the other two angles are congruent. 90 plus 45 plus 45 is 180. So when we'll call this an isosceles right triangle, or we will call this a 45, 45, 90 triangle. We will say both of those things, okay? All right, here's the deal. Let's call the leg of this isosceles right triangle x, which means the other one would also be x. It's isosceles. And let's call the hypotenuse c for right now. What I'm about to do for you is derive for you the formula that we're going to be using. The Pythagorean theorem then is x squared plus x squared is equal to c squared. I'm now going to solve for x. It will be in terms of c. We don't have any numbers here. Well, there's a number. X squared plus x squared is 2x squared. I'm now going to take the square root of both sides. I said I was going to solve for x. That's not what I did. I'm putting x and c, getting rid of the squares here. So the square root of 2 times x is c. What did we say x was? X is the leg. C is the hypotenuse. So the relationship between the leg and the hypotenuse is right here. The leg times the square root of 2 is c. That's what this is. So the hypotenuse is square root of 2 times as long as the leg. We'll see this in action here in just a second. The square root of 2 is the number you have to know that goes with a 45, 45, 90, or an isosceles right triangle. Square root of 2, square root of 2. Over the left-hand side, write square root of 2 with an exclamation point. Okay. So that is the relationship. So c is equal to x times the square root of 2. It's important to know that a 45, 45, 90 triangle is half of a square. So anytime you see a square with a diagonal, if you know one of the legs or know one of the sides, the diagonal is going to be that side times the square root of 2. So here's the deal. If you are given a leg, write this up here. A leg times the square root of 2 equals the hypotenuse. So if you're given the leg, which we are here in this first example, if the leg is equal to 7, well then the other leg, of course, is equal to 7. What's the hypotenuse then? The leg times the square root of 2 is the hypotenuse. What is 7 times the square root of 2? 7 times the square root of 2. That's the length of the hypotenuse. That's all there is to it. Okay? Moving on. If we know that a leg is 5 square root of 2, both of the legs are 5 square root of 2, how do you find the hypotenuse? If you have a leg, multiply by the square root of 2. So 5 times the square root of 5 square root of 2 times the square root of 2. Well, we have the square root of 2 times the square root of 2 is 2. So it's 5 times 2 is 10. This is why we did all that radical stuff earlier. So 10, if the leg is 5 square root of 2, the hypotenuse is 10 of an isosceles right triangle. What if it looks like this? If it's 2 square root of 10 is the leg. Well, how do you find the hypotenuse? The pattern is you multiply by the square root of 2. What's 10 square root of 2 times the square root of 2? That's 2 times the square root of 20. Now we have to simplify this radical. A 2 comes out, 5 stays in. 2 times 2 square root of 5 is 4 square root of 5. Yes, I know I just talked through that very quickly, but this is just like what we did when we did our radical lesson. We're multiplying this radical expression times the square root of 2 and then simplifying. Okay, so the process here, if you're given a leg, hopefully you see that that's all there is to it. You multiply the leg times the square root of 2 when you have a 45, 45, 90 triangle. What do you do if you're given the hypotenuse? If you're given the hypotenuse divided by the square root of 2 is equal to the leg. It's the opposite. Instead of multiplying by the square root of 2, we divide by the square root of 2. Okay? So if you're given the hypotenuse, in this case it's 6 times the square root of 2. If we want to find the length of the legs, x, I'm going to divide 6 square root of 2 by the square root of 2. Well, when you have something on the top, numerator and the denominator, they cancel each other out. What are we left with? 6. So if the hypotenuse is 6 square root of 2, each leg is equal to 6. Okay? Yes, it's that simple. Hopefully you see it that way. If the hypotenuse does not have a radical within it, well, when we divide 11 by the square root of 2, what happens? We have a radical on the denominator. What do we have to multiply by then to get rid of that radical? Square root of 2 over the square root of 2. We end up with 11 square root of 2 over 2, which then does not simplify, so each leg is equal to 11 square root of 2 over 2. But what happens when you have a radical on the denominator? You got to get rid of it. Look at question F. This looks like it's the most confusing one, but it's not. Check it out. If the hypotenuse is 2 square root of 10, what are we going to divide the hypotenuse by to find the leg? Square root of 2. When you have two numbers inside a radical, square root of 10 divided by the square root of 2, they cancel each other out. So it's 5 over 2 is what 5 over 1 is what 10 over 2 is equal to. So 2 square root of 5 is how that simplifies. Okay, here's what I'd like for you to do. We've got this table down here. A and B are both legs. So if you know what A is, you know what B is. If you know what B is, you know what A is. Okay? So the question is really, if you know what A or B is, find C. If you know what C is, the hypotenuse, find A or B. What are you doing? If you're given A and B, multiply by the square root of 2 to find C. If you're given C, the hypotenuse, divide by the square root of 2 to find A or B. See if you can fill out this chart. Every right triangle is the same. If you hadn't paused the video, you should have done that by now. All right, here are the answers. Okay, notice that A and B are always the same, and you're either multiplying by the square root of 2 or dividing by the square root of 2. That, my friends, is how 45-90 triangles work. The other special right triangle is a 30-60-90 triangle. I first want to derive where all this stuff comes from. Let's say you start off with an equilateral triangle where all the angles are 60 degrees, all the sides are congruent. I'm then going to drop an altitude. An equilateral triangle is an isosceles triangle, so it will cut those pieces in half, it cuts the angles in half, so we end up with two 30, 60, 90 triangles. So we're going to base this off of this. Now, in order to derive these formulas, I'm very strategically going to say let half of this leg down here, or let the small leg of this right triangle, or let half of this side of the triangle be A, which means the other side is A, which means A plus A is 2A. So the side of our equilateral triangle is 2A, and I'm doing that totally on purpose so that we can make these formulas. And then let's let the long leg of the right triangle be B. So in this case, that's the altitude. Now that's got a lot of stuff over there. I'm just going to now draw the right triangle. We've got a 30, 60, 90 triangle. The small leg is A. The hypotenuse is double A, 2 times A. And then the long leg is B. So the first thing is easy. The hypotenuse is twice as long as the short leg of a 30, 60, 90 triangle. The hypotenuse is twice as long as the short leg. Now to find how the larger leg and the shorter leg are related, I'm going to use the Pythagorean theorem. This is going to get ugly at first. A squared plus B squared equals 2A squared. Let's square the 2A. 2A squared is 4A squared. I'm going to get the A's together, minus A squared on both sides. 4A squared minus A squared is 3A squared. Square root of both sides. Square root of B squared is B, the square root of 3 is square root of 3, the square root of A squared is A. I'm left now with B, the long leg, is equal to A times the square root of 3. There's the relationship. That's where it comes from. Now I'm not going to ask that you reproduce this, but this is where it comes from. And so A times the square root of 3 is what B is equal to. So fill in this blank up here. The longer leg is the square root of 3 times as long as the shorter leg. You always will go through the shorter leg. Always through the short leg. Always. To find the hypotenuse, go through the short leg. To find the long leg, go through the short leg. Okay? Now, let's go over these examples on the back side. All right, example 1. If you're given the shorter leg, this is the easiest scenario. If you're given a shorter leg, the hypotenuse is double the shorter leg. The long leg is the shorter leg times the square root of 3. Let's see this in work. Okay. Question G here. If the shorter leg is 9, the hypotenuse is the short leg times 2, 18. Simple enough. The long leg is going to be the short leg times the square root of 3. 9 times the square root of 3. That's how it simplifies. We're done. What happens if there's a radical there? Well, Same process, we just will have radicals to deal with. If the short leg is the square root of 5, the hypotenuse is double that, 2 times the square root of 5. The long leg will be the square root of 5, the short leg, times the square root of 3. Short leg times the square root of 3. So square root of 5 times the square root of 3 is the square root of 15. So this process, we have 3 different side lengths here. So the number that you have to know with respect to a 30, 60, 90 triangle is the square root of 3. Write the square root of 3 with an exclamation point next to it over on the left-hand side of your page. Okay. If you're given the hypotenuse, what do you do differently? Well, you find the short leg first. The short leg is the hypotenuse divided by 2. Okay, instead of multiplying by 2, you divide by 2. And then you use the short leg to find the long leg still. You always use the short leg. Write that on the top of the page here. Always use the short leg. Okay, so if the hypotenuse is 20, how do you find the short leg? You divide by 2. So if the hypotenuse is 20, the short leg is 10. Let that be easy. The long leg, multiply the short leg times the square root of 3, just like you did up above. So find the short leg first, and then multiply by the square root of 3. The short leg here, divide by 2. Can you have a radical on the numerator? Yes, you can. Does that simplify at all? No, it doesn't. If the hypotenuse is the square root of 10, the short leg is the square root of 10 over 2. Now, to find the long leg, you multiply the square root of 10 over 2 times the square root of 3. Short leg times the square root of 3. What do you get? Square root of 30 over 2. Does that simplify? Square root of 30 does not simplify. That's your answer. It's an ugly answer, but that's your answer. All right, last piece of this puzzle. If you're given the longer leg, this is the most confusing of all of it, but the process need not be confusing. If you're given the long leg, to find the short leg, divide the long leg b by the square root of 3. Okay, to find the short leg, divide b, the long leg, by the square root of 3. So, question K here, the example. If you're given square root of 14, b, to find a, divide the square root of 14 by the square root of 3. Oh snap, radical in the denominator. Square root of 14 comes square root of 30 is square root of 42. The square root of 3 times the square root of 3 is 3. Square root of 42, in this case, does not simplify. So now that we know what the short leg is, a is the square root of 42 over 3, you multiply the short leg by 2 to get the hypotenuse. Always go through the short leg. Now this is an ugly looking answer, but that's your answer. Once you have the short leg, there was really no work to do. Just throw a 2 up there. 2 times the square root of 42 over 3. Okay, look at this example. Got the hypotenuse is equal, the long leg is equal to b. To find the short leg, you divide by the square root of 3. Got to get rid of that radical, so we have the 9 square root of 3 over 3. Reduce. The answer is 3 square root of 3. Now that we know the short leg, what can we do? We can find the hypotenuse. Always go through the short leg. 2 times 3 square root of 3 is 6 square root of 3, and we're done. Okay, like what you did on the front side, I'd like for you to fill in as much of this chart down here as you can. If you're given the short leg, find the long leg by multiplying by the square root of 3. Multiply by 2 to find the hypotenuse. If you're given the short leg, divide by square root of 3 to find a, and once you find a, you double it to find c. If you're given the hypotenuse, half of the hypotenuse divided by 2 is a. Multiply a times the square root of 3 to find b. That is your process. Pause if you didn't. Fill in as many blanks as you can. You should discover some patterns. These are the answers. All right, now this is just the 45, 45, 90 stuff in action. And what I'd like for you to do is there's 9 questions down here. No, I'm sorry, there's 11 questions. I'd like for you to choose 6 of them and give them your best shot. If you want to do all 11, good for you, but I'm requiring that you do 6. Give them your best shot. There's 45, 45, 90 triangles. There's 30, 60, 90 triangles. There are the answers. I hope you have a great rest of your day. Get some rest. Bye-bye.